welcome to Excellence in Academy. For today, we'll be discussing about a very important aspect in mathematics known as complex number. For today, we're discussing about the definition of a complex number and the algebra of complex number. By the word complex number does not mean it's a very hard or perhaps a complex stuff to do. Actually, it's a very simple concept, right? So let's discuss the definition of complex number. By definition, a complex number is simply any number in the form a plus ib, a plus ib, where a and b are called real number. By real number, we mean either positive or negative number. Where the value of I is equal to the square root of negative 1, right? So, by the word complex number is a number expressed in terms of what? A plus ib, right? Where I is equal to square root of negative 1. Alright, during the 16th century, it was difficult to find the square root of a negative term. For instance, if I have root minus 4, this would have not been possible until when I was equal to root negative 1 was invented. So this gives us the edge and the ability to find the square root of a negative term. How? If I have root minus 4, that becomes, from the concept of sort, I can write it as saying root 4 times minus 1 and still correct. Of course, from that same concept of sort, I have root 4 times root minus 1 and still correct. Root 4 becomes 2 times root minus 4 becomes root minus 1. But we just said root minus 1 to be what? I. So I have 2 times I, which is equal to what? 2i. So complex number has now given us the edge to find the square root of a negative term. For instance, root minus 4 is equal to what? 2i. Some example of complex number are as follows. If I have 3 plus 4i, it's a what? It's a complex number. If I have 3 perhaps let's say 10 plus 16i, it's still what? It's still a complex number. Alright, let's move to the next concept called the representation of a complex number. Having discussed the definition and the concept of complex number, let's discuss the representation of a complex number. Alright, representation of a complex number. How do we represent a complex number? Right? There are 3 distinct ways of representing a complex number. Number 1 is called the rectangular form or the Cartesian form. Number 1 is called the rectangular form. Rectangular form or perhaps the Cartesian form. Number 1, we have what we call the rectangular form or the Cartesian form of representing the complex number, right? So the complex number in the form a plus ib. This is a what? A rectangular or Cartesian form of representing a complex number. Or perhaps if I have a comma b, this is a what? A example of how to identify a rectangular or perhaps a Cartesian form of complex number. So let's say I have z to be equal to 3 plus 4i. I say this is a what? A rectangular form of representing what? A complex number. Alright, the second method is called the polar form or perhaps circular form. The second method is what? The second representation of complex number is called the polar form or the circular form, which is given as let's say z is equal to r into cos theta plus I sin theta, where r is called the of a complex number, and theta is called the amplitude of a half argument of a complex number, right? So note that if I see a complex number as r into cos theta plus I sin theta, is simply what is simply a polar form. So this is a polar form of a half circular form of representing what a complex number. The last one is called the exponential of a half, the Euler's form. Of a half, the Euler form of representing a complex number. So how to represent exponential of a half Euler's form is given as as r exponential I into theta. This if you see any complex number in this form, it's said to be what the exponential of a half Euler form of representing a complex number. So these are the three distinct ways of representing a complex number. Alright, let's move to the next concept known as the algebra of complex number. By algebra of complex number, we mean how to add complex number, how to multiply, how to subtract, even how to divide a complex number. Alright, the algebra of complex number. By algebra of complex number, we mean how to add a complex number, how to subtract a complex number, how to multiply, even how to divide a complex number. Let's have the first one, known as the addition of a complex number. Addition of complex number. Number one, addition of complex number. How do we add a complex number? Given two complex numbers, z1 and z2, given two complex numbers, z1 to be equal to a1 plus ib1, given the second complex number, z2 to be equal to a2 plus ib2. Now listen please, at this point, note two things, or perhaps note something please. Note that a1 and a2 are called real numbers, right? While ib1 and ib2 are called the imaginary parts. So listen, a1 and a2 are called the real parts, ib1 and ib2 are called the imaginary parts. So the part that has I with it is called the imaginary part. So how do we add these two complex numbers? So to find z1 plus z2, simply add the two. That becomes z1 is this. I have a1 plus ib1 plus a2 plus ib2. So z1 plus z2. z1 is this. I have this. Plus z2 is this. I have this. At this point, z1 and z2, z1 plus z2 will be equal in value to, open the brackets, I'll have a1 plus ib1 plus a2 plus ib2. We just said something now. What did we say? We said add the what? Real part together. By the real part, we mean a1 and a2. So what the real part here? My real part here is what then? a1 next up plus a2. Next up, add their imaginary part. What's the imaginary part here? I have plus ib1 plus ib2. At this point, I'll factorize I outside here. I'll have a1 plus a2 plus I into b1 plus b2. Of course, I times b1, ib1, I times b2, ib2. Of course, this is how to add a complex number. Example, if I have, let's say, I have z1 to be equal to 3 plus 4i and I have z2 to be equal to 2 plus I. Perhaps 1 is the coefficient of I here, while 4 is simply what the coefficient of I here. So I'm going to find z1 plus z2. What do? Add this now together. Hence, z1 plus z2 is equal to 3 plus 4I plus what there? Z2 is what? 2 plus I. Of course, open the brackets. I'll have 3 plus 4I. Next one, plus 2 plus I. We said at this point, add the green part together. For the green part, we have 3 and 2. So that becomes 3 plus 2. Okay, have 3 plus 2. Next up, look at the dividing part. That becomes plus 4I plus I. At this point, 3 plus 2 becomes what then? 5. Next up, or perhaps z1 plus z2 value to be equal to 3 plus 2 is what then? I have 5. Next up, plus 4I plus I becomes 5I. So this has to add two complex number. So this is like the concept of addition of a complex number. Alright, let's discuss the subtraction of a complex number. Right? How do you subtract a complex number? Given to a complex number, z1 and z2, z1 to be equal to a1 plus ib1, and z2 to be a2 plus ib2. How do you subtract these two complex numbers? Hence, z1 minus z2 becomes, z1 is what? a1 plus ib1. I have a1 plus ib1. Next up, minus what then? a2 plus ib2. Next up, expand the bracket, or perhaps open the bracket. a1 plus ib1. Next up, minus times a squared, minus times a. I have minus a2. Next up, minus times plus what? Minus ib2. At this point, I'll take the parts together. So I have a1 minus a2. Next up, plus ib1. Next up, minus ib2. At this point, I'll have a1 of a half. The value for z1 minus z2 is now equal in value to a1 plus a2. Next up, I'll press I out here, plus into, perhaps, plus I into b1 minus b2. Right? So, plus I times b1, that's plus ib1, plus times minus is what? Minus I times b2 is what? ib2. Alright, this is how to subtract a complex number, right? So, perhaps, let's take an example first. I'll show you something. Let's take an example. Example, let's say I have z1 to be equal to 4 plus 2i, and I have z2 to be equal to 2 plus 2i. I'm told to find z1 minus z2. What do? First things first, z1 minus z2 is equal to what then? This man here, 4 plus 2i, minus the second man here, 2 plus 2i. Perhaps at this point, I'll have that 4 plus 2i. Next up, minus times 2 becomes minus 2. Minus times plus equals minus, then what then? 2i. At this point, I'll bring out what? The real part together. That becomes 4 minus 2. Next up, the imaginary part plus 2i. Next up, minus 2i. Of course, plus 2i. Plus 2i. Next up, minus 2i. At this point, I'll have z1 minus z2 to be equal to 4 minus 2 is what then? I have 2 plus I, or perhaps 2i minus I is 0. So my answer here becomes 2, right? Now listen. I can choose to use this formula to find my Z1, Z2. So perhaps my answer. Let's say I don't want to solve this math directly. I can still apply this concept, this formula to solve that man, this one here. Note that A1 is this, A2 is this, right? So I have A1 to be equal to 4. I have A2, this one here to be 2. Next up, I have I is constant there. B1, we said B1 is this here. So the value here is B1. So B1 is equal to 2. Next up, B2, I have B2. B2 is also what there? Is also 2. Right? So I can put this value here into my formula here. I'll still derive by the same answer here. Let's do that together. I have Z1 plus Z2 is equal to A1. We just said A1 is 4. I have 4. Next up, plus A2 is 2. From here, A2 is 2. I have 2. Plus I into B1. Check. What's B1? We just said B1 to be 2. Plus 2 is 2 here. Next up, minus B2 is same as 2. Finally, Z1 plus Z2 is equal to 4 plus 2. Okay, half. 4 plus 2 becomes what then? 6. Alright. 4 minus 2. Okay. Sorry. Alright, at this point, I have A1 minus A2. Hence, it will be A1 minus A2 per se, please. A1 minus A2, please. A1 minus A2. So at this point, I will have what then? Minus here, please. Minus here. So 4 minus 2 becomes 2 plus I. This is 0. So hence, I times 0 is 0. So my final answer becomes 2. This is how I got to here. So instead of solving directly, you can also apply the formula to solve it. Please note that there's a mistake here. The mistake is quite simple. I put positive here. It should be negative. So A1 minus A2 plus IB1 minus IB2. So I have Z1 minus Z2 to equal to A1 minus A2. Similarly, I'll factorize I out. This is I out. So 1 plus IB1 plus I times B1 is IB1. Next up, plus times minus I times B2 is IB2. So this is how to subtract problem under complex number. Now next class, we discuss how to multiply, even how to divide a complex number.